So in today's session, we are going to focus on a recommendation system. So what is a recommendation system? Recommendation system is to recommend products based on few things like similar behavior of users or similar items. So if we talk about recommendation system, then broadly we have these categories of recommendation system: popularity based, content based, collaborative filtering, and hybrid filtering. So in popularity based, we are simply recommending those products which are in trending and which are famous products, and the it is a very simple approach to recommend systems to the users, recommend products to the users. And the next is content based and collaborative filtering and hybrid. So in content based filtering, we are items to the user which are similar items. So in content based filtering, we are recommending similar items to the user. And if we talk about collaborative filtering, where our focus will be to draw a relationship between different users and recommend those items to the users which have similarities. So in hybrid, we can combine these approaches. So let's suppose we have to recommend movies in a movie recommender system, and in content-based filtering, if user is watching a movie, then we can recommend similar movies to the users. So this is a content-based filtering. And if we talk about collaborative filtering, we can build relationship between different users. And if user one is watching, let's suppose a movie, and user two is also watching a movie, and both users are giving a 5-star rating to this movie, then we can, and in the next step, if user one will watch another movie and that user will give 5-star rating to this movie, then we recommend this movie to the second users because previous behavior of both the users was same. So let's suppose we have a movie recommendation system, then what we will have to use as data set. So we have a data set of users and movies records, and we can apply some filtering and prediction algorithms to predict movies accordingly. So as we saw in the last session, that we were computing Euclidean distance in the k-mean clustering algorithm and hierarchical clustering algorithm. So where we use Euclidean distance to calculate the distance. And in the same way, we can also calculate similarity between users or between products to movies. Let's suppose here we have M1 and M2, let's suppose user 1 and user 2. If user 1 is liking a movie and user 2 don't want to watch that movie, then they both users have different behaviors. So we can calculate their Euclidean distance by plotting vectors on our 2D plan. And in the same way, if we want to measure the similarity between the users, then let's suppose here we have a vector of user 1, and we can compute what is the vector. Vector is in simple way, if we talk about data set. In data set, vector means a single row, a single record is a vector. So all the features of a user is a vector of that user. So Here in 2D plane, we have user one vector and user two vector. And if we want to calculate similarity between these users, we can calculate the similarity by calculating angular distance. And how we can calculate angular distance? We can use different similarity measurement formulas, or you can say algorithm that are available. For example, a very well-known algorithm to measure similarity between different users is cosine similarity. So we will apply these in the implementation. So, if we talk about the challenges and issues in recommendation system, so one major issue to handle unknown users or unknown let's suppose if a new user is joining uh, and that user don't have any previous record for the prediction. So how we can show prediction to this user? So this is another big issue is the scalability. We have e-commerce website or let's say Amazon, or we have Netflix, or any book recommendation system company. So they have a large big data. So how they can manipulate and use that big data to perform recommendations. So this is another challenge. And one other major challenge is to deal with the dynamic updates. So how we can react with changes that are happening time to time with the user and with the companies. So trending, maybe trends that would change. So another is data sparsity, where we have lots of missing values of by the users. So if we do the user don't have much knowledge, so how we can form a prediction for this user. So today our focus in the implementation point is to take two examples to implement recommendation system. One is a book recommendation system and the other is movies recommender system. So let's start the implementation work. So first of all, we are going to build a book system uh, where we have record of books and records of users who purchased that book, and record of ratings, which user is already had rated to which book. So first of all, we are importing libraries and then importing data set from Google Drive. So another thing, if you want to do work in Google Colab in a fast way, then you can go to runtime option and then change runtime type. And here you can select GPU if you want to increase the performance, if you are going to train any model, any deep learning model or any model. So we have imported three types. Basically, these are data sets of books. So one data set is books, and another is users, and the third data set is rating data set. So these are data sets are related to books. If we want to print any attribute from the book dataset, then we can give column name and then giving index to print that. For example, if we want to check the image URL of this book, then we can do this, and this is the URL of a cover image of this book. If you want to uh, check this image, you can simply search it on Google and it will show you all the image of this book. So Here, uh, let's see first five records of books dataset. So here we have a book title, book author, year of publish, and publisher by university, any university name or anything, and image URL. And let's see users first five record. Here user ID, user location and age, and so on. Ratings first five records. A rating mean movie ID, title of the movie, and user ID who rated this movie, and rating uh, from 1 to 5 star. So let's check the shape of these data sets. So in books data set, we have 2,71,360 and 8 columns and so on in the users data set and in the rating data sets. So let's check if we have any null value in our data set by calling is null dot sum method. Is null a method will return it, pandas method that will return any value that has null, and dot sum method, by applying dot sum method it will merge all the is null values and give only counted value. So in books dataset, we have one null value in authors record, and two null value in publisher record, and three UR. So we can drop these. So let's check users null value. And ratings null value in the data in users data set, we don't have any null value, and but in the column of age we have lots of null values. So as in this case we don't need to use age data set, so age column, so we can drop this column later on, but we have lots of null values in age data set, age column. And in ratings dataset, we don't have any value. Let's check if we have any duplicate value. And in books dataset, we don't have any duplicate value in dataset. Uh, let's run the cell. In ratings dataset, we also don't have any null value. Sorry, duplicate value. And in users dataset, we also don't have any duplicate value. So one simple approach is to build recommendation system is a popularity-based recommending system. In popularity-based recommending system, we are only recommending those products or items that are popular in these days, and we will we will recommend these popular items to all the users. You can consider it if we you can take example of YouTube, then a trending section in the YouTube is the example of popularity based system. So we are merging ratings with the name dataset. So with the books dataset, so in this we are combining all these three datasets into one dataset. So in this column, in this cell, we're merging ratings and books dataset in one dataset. So I think we have an error. So let's check the error. Let's run these cells. Taking for the null and duplicate values. So maybe we had any error, but no, it's done. We have merged the rating dataset with the books dataset. And next step here, we have to count how many ratings we have for all the in the rating with name dataset that we have just combined and then calling group by method. It is similar that we have in the SQL method to group into book title. So group by, and we are passing book title and counting how many ratings we have for each book, and then just renaming the new dataset with the book rating and the num rating. And let's print it. So in the first column, we have book title, and in the second column, we have number of ratings for these books. So our aim is to recommend those books which have more ratings as compared to other books. So we need to recommend popular books to the users. So we are taking average of ratings. Here we just combine previous number of rating book title along with the average rating. So here we are only considering those books which have ratings more than 250. So we will drop all the other books and only will keep those books that have ratings more than 25. And only considering first 50 books. And less dropping duplicate values here if books are duplicate. So if we want check, for example, first 10 most popular, then we use like popular df dot head and giving 10. So here we have top 10 most popular books, their title, book author, their cover pictures. See, all these books are all these books have rated more than 250. So these are 10 most popular books, and we can if we want to recommend others, then we can recommend these books to the user based on popularity. So this was all about uh, recommending based on popularity. So the next thing is, if we want to perform recommendation based on collaborative filtering. So remember what was the collaborative filtering? Collaborative filtering is to recommend uh, um, books to the user, we can say books or any item to the user based on users' similar behaviors. So if user one is reading the same book and user two is reading the same book and both are giving 5 ratings to this book, then if user one will read another book, then we can, and that user will give 5 ratings as well to second book, then we can recommend this second book to the second user. So this is a collaborative filter. So here we are to perform collaborative filtering, we are considering two things. First of all, we are taking books data sets that we use in the previous example. And this data set is a benchmark data set and publicly available. And we are considering two criteria to perform collaborative filtering. The first criteria is to take only those users who gave rating more than 200, and the second criteria is to consider only those books who have ratings more than 50. So here in the first column, we are extracting those users who have books ratings more than 200. So we are extracting those users and storing in the variable X. And in the next line, we are taking indexes of those users. You can consider IDs of those users. So let's run this cell. We are taking users who have book rating more than 200. And in this cell, now we will have to extract only those books which have rating more than 50. We can name it as famous books. And in the final rating, we will combine both of these data sets. So we are considering only those books titles have 1% book rating, and only taking users which have more than 200 ratings. So as if you can see here, next step, if you want to perform collaborative filtering, we have to convert our data set in a vector form. What meaning of this? We have to use plot our data set in a 2D plane, where one x-axis you can say will represent one entity, and another y-axis will represent another entity, and values will represent their similarities. So like this, we'll have to draw a vector. So this is we are going to plot now, and we are using pivot table to uh, draw a 2D matrix to perform um, cosine similarity and to get those users which are similar in behavior. So what is pivot table? If we have a large data set and that data set has different dimensions, then we can view data set from different dimensions with the help of pivot tables. So in the final ratings data set, we are calling pivot table and providing index as book title and column name user ID and value equal to book ratings. So let's run this cell. And removing null values here if we have in the dataset, pivot dataset. And here is the pivot dataset. So as you can see in the columns, we have user IDs, and in the indexes, or you can see in the rows, we have book ID, and their values are representing to the ratings. So you can consider it as every book has a one record, and every one record, we can name it as vector of this book. So this is the thing that we can use to perform cosine similarity. So cosine similarity, to perform cosine similarity, we are importing cosine similarity from sklearn library. And cosine similarity is a simple way to check the similarity or behavior of different users based on rating that they already have given to these books. So just calling cosine similarity and passing pivot table. What is pivot table? Pivot table in this case, just it is a 2D array that has book title in rows and user ID in columns and book rating in the values. So let's run the cell. And similarity scores will represent all the relationship between these books. So here, 706 and 706 rows and columns. What is meaning of this? Here we have built the relationship between all the books. So what is the relation of one book with other all books? So let's suppose how we draw this based on user rating that they have already given to these books. So till now, what we have done, we calculated cosine similarity with the help of pivot table. And what is our output? Our output is similarity scores. Can you please mute your mouth, mic? So the next step is to build recommendation based on these similarity scores. So here we have our recommendation algorithm. So every company has its own recommendation algorithm. It's something fixed or it's not something that we cannot change. So company may have every company may has its own recommendation system, and we can also use other measurements to calculate cosine similarity, but in this case we are using cosine similarity. So in this algorithm, we are extracting text of book by giving book name from the PT table. What is PT table? PT table is that we already calculated pivot table. And calculate what is the next step? Just pass index in the similarity scores to get similarity of this book, and just sort it. So why we are sorting? To get similar books in ascending or descending order according to our requirement. And here we are printing all the similarity items. So here we are only recommending 5 books by giving book name. So if we can why we are giving one, because in zero index we have that book also, that here we are passing as book name, so we don't need to consider that book. That's why we are starting from one, only including 5 similar books. So let's run this cell. So next step is to call this function, Python function, and and we will pass book name in this function to perform prediction. So here we pass Year of Wonders as book name, and the algorithm recommend other similar books. So we are considering only 5 books. For example, if we want to print 10 similar books, then instead of writing here 5, we can write, let's suppose 10, and let's give the book name again. And now is this time algorithm will predict, or you can say recommend 10 related books. So in next step here, we are taking another example, that is performing movie recommendation system based on collaborative. We are importing required libraries, pandas, scipy, sklearn, importing set from Google Colab. So here we have two dataset: ratings dataset of movies dataset itself. And uh, in the next line here, we are merging movies and rating dataset and dropping 2 columns that are not required in this case. So this is our final dataset where we have movie ID, title of the movie, user ID, and their corresponding ratings that they already had given to these movies. So let's draw the pivot table based on user, where we have user ID in rows, column. In the columns we have title and values are ratings. So this is the pivot table. So as you can see, we have lots of values in this pivot tables. This is the problem of uh, data sparsity that we discussed in the slides. So we need to drop all the null values, and we only have to consider we will have to remove those movies which have less than 10 users who rated it, and will remain all the remaining null values with the zeros. So let's run it. So here we have pivot table, where in the rows we have user ID, and in the column there are titles of movies, and values are representing to the ratings given by the user to these movies. So to consider similarity, or you can say to get similarity scores, we are in this time we are not considering cosine similarity, but we are building a correlation and using Pearson method to draw correlation. So in this method, it is a very simple method to draw a correlation between two entities, and the range will be from -1 to 1. 1 means these two entities are more similar with each, and -1 means they are different. And in this time, our algorithm to get similar movies just pass the movie name and user rating for this movie, and calculating item similarity by giving movie name and multiplying it with the user ID and subtracting with 2.5. It's just a random way to write 2.5. You can consider any, you can propose your own algorithm as well. So if we want to perform predictions, so let's suppose we have this user that likes action movies, and first this user has watched this movie and gave 5 rating, that is action movie in the time. that person watch a sci-fi movie to give one rating. One rating means this person don't like to watch this type of movies, and in the next time same person uh, have watched any other movie that is not related to action and give one rating, and this is the behavior of our user. So using for loop, just one by one give uh, movie and rating to the get similarity method that we defined in the previous cell, and appending all, and get similar movies method will give all the names of movies that have similar score. You can say similar correlation. Let's run the cell, and here it will give a title of movies that are and that are recommended for this user. So, any question? We can use OpenCV, but OpenCV is specifically related to images. So we can read a dataset with OpenCV, but that is related to images. And group by is meaning grouping things and counting things based on given value. But pivot table is uh, to watch dataset from different dimensions. Any question? Okay, Zee, thank you.
Okay, so thank you very much, Mr. Klim, to deliver the lecture today. Okay, so any student have if any questions, so you can ask, please. Or any other want to comment some, or want to share something, you can. Yeah, and Mm. Mm. Okay, so if you don't have any questions, so okay, if anyone don't have any questions, so we will conclude the lecture here, and please open your webcam and we will take a picture. So then we will finish the lecture here. Okay, so everyone please open your webcam so we'll take a picture together. So then we will conclude lecture here. Okay, so the last lecture will be on Monday, next week on Monday, 28th of the March. So then the data science course will be finished, will be completed. So then we will share with you the questionnaire. So then after completing and submitting the questionnaire, so we will share the certificates with you. Okay, please wait. Someone ask one question, please. Also, Mr. Klim, someone asked a question in the chat. So what is the in pivot position?
Yes. Here we are considering to the array to draw pivot table, and we can consider, for example, we have two entities and we want to draw a pivot table for these entities, then we can consider any in the columns and vice versa. So there is no there is not a fixed thing. For example, if we have in rows user ID, then we can also write user ID in the columns. And what will be their values? Their values will be corresponding, you can say in this case, rating of movies or ratings of books.
Right. Okay, any other candidate student have any questions? So you can ask, please. Okay, so we will conclude the lecture here. Okay, so please open your webcam. So we will take a picture. So then we will finish the lecture. Okay, so I will take a picture now. Please smile. Okay, so thank you very much for joining the lecture. So okay, we will see you in the last lecture, which will be on 20th of March. Thank you very much.
Thank you very much.